Hey there, welcome back to my channel. So today I'll be starting the tree series. So first we'll touch up the very easiest questions, that is traversals part. So today I'll be talking about Inorder Traversal. So you see, so what is this Inorder Traversal? Let's take an example so that we'll better understand what this traversal is about. Okay, so I'll take one big example. So let's say, like, one, okay, two, and three, 4, 5, 6, 7, something like this, 8, 9, 10. Okay, so assuming this is the example we are given, and we should be able to extract the in-order traversal of this example. So, and our output would be like this. Let's write this as output. Output for this example of in-order traversal would be 4, 2, 8, 5, 1, 6, 3, 9, 7, 10. Okay, this should be the output. Fine. Now how are we going to achieve this? That's the question which would be trying to solve. Okay, first let me put this output in the above part. So I'll put here, okay, so let me reduce this size as well. One second. Fine, right? This is the output. So the simple logic for the in-order traversal is here, the which I have already highlighted. We should keep recursively traverse to the left child of the given node until unless there is no more left child left for that node, and print that value. And later go back to its parent, print that value, and check for its right child. If there is a right child, again do the same process of recursively traversing that left parent right logic. Okay, so I think I'll walk you through that process in the for this example, so that it will be clear. Okay, so assuming first we will be at this node. Okay, this is the root node. So I'll check whether there is a left child for this node or not. Yes, there is. So then I will come to this node. Okay, I am at this node currently. Again I'll check for this if there is a left child for this. Yes, there is. So again I'll come back. I'll come to this left child, 4. So now I'll check for left child. Is there a left child? No. So there is no left child, and what I'll do, I will directly print the current value of the node I am at. Okay, again check for the right node. Is there a right node? No. Right? So there is no more right node. Again go back to its parent. We traversed back to its parent, so again print that value here too. Okay, is there a right child for this root node, node 2? Yes, so we'll move back to its right child. Again for this node 5, is there a left child? Yes, so go back to its left child. Again, is there a left child for this? No, so we will print this. Right child? No, so traverse back to its parent, print that parent. No right child, so move back to its parent 2, it's already printed. Again move back to its parent 1, so print that value. Is there a right child for this? Yes, go to its right child. 3, is there a left child? Yes, go to its left child. 6, left child? No, so print that value 6. Again check for the right child. No, so go back to its parent, print that value. Go for right child of node 3, that is 7. Is there a left child? Yes, go visit its left child. Again check for the left child of a node 9. No, so print that 9. And right child? No, so traverse back to its parent, print that parent, and go for its right child. Is there a left child for this? No, so print that root value and check for right child. No, so this is exactly what we need, right? So this is how the process of traversal looks like. Okay, that is 4, 2, 8, 5, 1, 6, 3, 9, 7, 10. Okay, so So this was the at high level how the traversal and how the traversal will be happening, that is in our traversal. So now the simple logic for writing a code will be the I'll write pseudocode later on. After explanation is done, we'll try to code this part. Okay, first we check for I mean, let's say this is like in order traversal function, and there is root node, and check for if root is null. Some base condition should be there in recursive function, right? So if root is null, we'll return, or else I mean traverse left part of its node, that is root to left. Okay, if not, just print that root value, and here traverse towards right child. Okay, fine. So this is the simple pseudocode. So now I will try to explain the function calls in using the stack. I mean, so how functions calls are happening, how the value will be written, so that it will be very clear for us. So let's take the above example itself. Okay, so first I'll take a simple. So as I said, we are at this root node 1. So I'll take one stack here. So this initially we are at this first node. So we are at this first node. So we'll come and check if root is equals to null, return no. So it's not null. We'll go again in order to traverse the root to left. Left child of that is 2. Okay. So here again we'll add that 2 again. Starting of this function is root equals to null, no. So again traverse to the left part of a left child of this root node 2, so that is 4. Okay, I added this 4. Fine. Now again, is root equals to null, no. So we'll traverse the left part of its node 4. Okay, again, so here there is nothing, so we'll keep it as a null, n for null. Okay, and check if root is equals to null, yes. So what we'll do in that situation is we just return back to previous function call. Okay, that is we return here. So next would be like this. I mean, how the call stack looks like is this 2 and 4. Okay, we came to the this previous this we are at this point now. So that root to left was done. So what we'll do is next step is print root to value. So here we will print 4. Okay, fine. So again printing is done. Again one more recursive call in order traversal root to right. So that what happens is, so I'll draw one more stack here. Again same 1, 2, 4. Okay, so now the right part, again check for the right child. Again there is no node, so we'll push the null. Okay, just showcasing. And now check root value is equals to null, yes. So again we will return to this part. Since it is null, we'll return to this part. Fine. So how this stack again looks like this is this 2. Fine. And the right child traversal of 4 is also done. So this also will be, we will return this as well. I mean this would be done. I mean this call stack looks like this after this. That is, I mean this, we will come back to this part. So here this is how it looks like. Okay, fine. So now we are at this 2th node, that is this one again. So we will print the print 2 here. Okay, and then next go to the next part of our code, that is in order to traverse root to right. Is there a right child for this? Yes. Is there a right child? Yes. So what is that right child? 5. Okay, so I will push 5 Again check again, is root equals to null? No. So again I'll push the left child of the 5. Left child of 5 here is 8. Okay, so 8 is pushed. And again check, is root 8 equals to null? No. Traverse again left part of the 8th node. Okay, I will add one more here. 1, 2, 5, 8, and left part is null. So I'll add just null. Again check if root is equals to null. Yes. So we will return here. We'll return back to its parent. Once we return back to its parent, we will wait. I will draw this again. 1, 2, 5, 8. So now we will print this value, that is 8. Okay, 4 was printed, 2 is printed, and now 8 is printed. So next again what we will do, we will go for the right part of a right child of the node 8. Again there is no child, so it will be returned back, again come back to the 8, and that will also be completed. And after that the stack would look like this, that is 1, 2, and 5. Fine. So we went back to its parent 5. Now we will print that as well, that is we will print its value as well. So this is 5. One second. So we will print this 5 as well. So now check for the right child of 5. Is there a right child? No. Again, so I'll be pushing null. Again check for the root is null, so return. Again it will come back to the 5. So there is no more the code part traversal is left, so that will also be removed. So next the call stack looks like this, that is 1 and 2. So this is how it looks like. Now we came to the tooth node. So there we will print this was already printed, and there is no more traversal left for this as well. So we will remove this as well, that is this part is also done, traversal. So we'll go back to its parent. Now we are at this, so here we will print the 1 and check for right child of this node 1. Here is there a right child? Yes, 3. Okay, so again we'll push here, we'll push 3. Okay, and check is equal to null? No. Again we will go for the left child of it. The left child is 6 here. Okay, the left child is 6, and again check for it is equal to null? No. So again check for left child. Now in this case there is no more childs left, 6 or right child or left child is not there, so we will print this one, print 6. So like this the recursion stack will look like. So finally what output we'll be getting is this one. First we printed 4, then second we printed 2, and then later we printed 8, then 5, then 1, 6. Okay, so 6 was done. We went back to its parent, again that has to be printed. Okay, and we come back to go back to the right child of 3, that is 7. Check for if there is a left child. Yes, there is 9. Again check for its left and right, again print that. So finally the output would look like this, 9, 7, 10. So this is how the traversal of the code would look like. Okay, so I just try to explain in the form of a function call stacks, not completely, but gave you the gist of how this call works. Okay, so if we are clear with this, I think any recursion function calls we would be good to achieve the thing we need. So mostly in the trees data structure, recursion is very important, and we should understand how the calling will happen. Fine. So that was the thing, the how at high level how this works I wanted to talk about. So now we'll directly go to coding part and write the code for this Inorder Traversal and see the output. Okay, fine. So I'm here. I have created just a simple inorder.cpp file. So here we'll start coding in for this Inorder Traversal. So let me write this IO stream and also the namespace, pretty standard. Okay, and define the data type for this node. I mean design our own data type for this node. Okay, so this will have value and left and right pointer. Okay, okay, so this is simple thing, and let's write one function where so let's write return type as void only. So okay, so let name this as in order traversal, and for this input parameters would be one node, and also I will pass in order vector as a reference. Okay, so now we'll check here base condition. If root equals to null, we will just return here, or else we will recursively traverse the left part of the node, that is left child of a node. So that is root to left, and keep this as same. Okay, fine. And okay, this should be just singular mark. And now here I will push the root value here, push back root to val, or else we will again recursively traverse the right child of a particular node, root to right, and pass this one. Okay, so what's wrong with this? Okay, I should declare, I mean include this vector. Okay, I think the error should go, mostly it should go. 1 second. Yes, so that was the in-order traversal function which we need. And also I'll create one more just function creating a new node. So I'll name this as a new node, and here I will initialize the node value and left and right pointers for this particular node. Okay, so let's make that as struct node star some temp, and I will once again okay, I will create the allocate memory for this. That is whatever memory is needed for this yeah, so whatever is memory is needed for this node I will allocate, and then I will assign the value for this, and left and right pointers I will keep it as null. Okay, so this is just to initialize the node with values and left and right pointers. Okay, and there is some error. Okay, I forgot this. Yes, so now let's create the example which, and also this return, we'll return the temp. So return type is struct node star, right? So here I will initialize first with the example I explained. So the same structure we'll use here as well. So root node would be 1, okay, and then for this root to left would be 2, okay, and root to right would be new node of 3, and root to left would be new node of 4, okay, and root to left to right is new node of 5, okay, and root to left to right to left would be new node of 8. This is just, I'm constructing the tree which I've showcased just a while ago, okay, and so again root to right to left is new node of 6, and root to right is new node of 7, and root to right to left is new node of 9, okay. So similarly one more last thing is left, root to right to right. So this is the 10, okay. So we're almost done constructing the tree, and let me define the one array to store the traversal of our tree, and then I will call the function which we have written, that is Inorder Traversal, and pass the root and also the Inorder array. Finally what we'll be having here is, so let me print that as like Inorder Traversal, something like that, okay. And so here we will iterate through that array and print the values what it is containing, and let's check if the values inserted into that array is of the required answer or not, okay. So carry out in order of 5, and I'll give some space, okay, and just one sec, this return as 0, okay. So let's execute this and check what the output will be. Yeah, as we see the output 4 2 8 5 1 6 3 9 7 10, exactly what we had derived in the previous explanation, okay. So that is it for this video. This is the Inorder Traversal, and yeah, pretty much please stay tuned for upcoming videos. Thank you so much.